So we are going to solve rational equations. So I'm going to give you some step-by-steps. We'll try a couple of these here. So first of all, let's just kind of break down what they are. A rational equation. We've been dealing with a lot of rational expressions. So remember, rational really kind of just is indicating fractions. So they're just equations. Remember, equations are things that have equal signs in them. So I have equal signs and there's fractions. That's all that this is, okay? And it's not as bad as you think. Let me ask you this question. If I had, how about 2/7, bless you, plus x over 7 equals, I don't know, 5/7. Don't you know the answer to this? It's got to be a 3, right? 2/7 plus how many sevens gets me 5/7? 3, right? 3/7, 2/7 plus 3/7 would be 5/7.
Oh.
So the number that goes in for x is 3. Does everybody agree? Does this answer change at all if I didn't even have them as a fraction, if it was just 2 plus x equals 5? Isn't my answer still 3? So that's basically what we're going to do here. As long as all of my denominators are the same, you get to ignore them, because it's not going to change the answer for the numerator. Okay, so to solve rational equations, your first step is to get all the denominators the same. All of them on both sides of the equal sign. So we are going to get all denominators the same. Not yet. We will be. How do you get them all the same? Well, in order to do that, if there's any denominators that need to be factored, we're going to do that. So let's say to do that, you're going to first factor denominators. You're going to multiply whatever fractions need whatever pieces, just like we were doing on the adding and subtracting stuff. So factor denominators, multiply as necessary to get common denominators. And once you have those common denominators, you literally just ignore them. You're just going to solve the equation that's along the numerators. Solve the equation of the numerators. Ignore denominators. And that's it. So we only have a couple steps. They're not impossible. I just have to make sure that I'm doing it in the right order. If I already have common denominators, great, I'm ready to go. If I don't, I'm going to try and get them. Hopefully it's not too bad. And then I'll just solve the equation of the numerators. Give you a second to get that all down. Okay. Maybe not yet. Okay. Okay, we're good? All right, so let's look at this worksheet. And let's just start on the first one. That's fine. So, step 1, get all the denominators the same. To do that, I want to factor the denominators, multiply as necessary to get the common denominator. Okay, so my denominators are not all the same right now. And there's nothing really for me to factor here either, so I can't really do that. But I can multiply things to make them match. So, let's start with the numbers. These both have 5, so I'll have to multiply this one by 5 over 5, right? At least, so that everybody has a 5. Okay, so let's multiply this one by 5 over 5. And then, okay, you two match, your 5r and your 5r, but your 5r squared. So what else am I going to have to do to make a match? Yeah, this one's going to need to be multiplied by another r, and so is this one. So this one, I'll just multiply by another r over r, and same thing on this last one, needs r over r. Now, everybody's denominator is 5r squared. Do we agree? So now I can ignore those denominators. So check this out. This first thing, if I multiply this all together, isn't that just 5r? Right? Does everybody agree? So I have 5r equals 2, and then 1 times r is just r, so minus r. That's it. That's all I get to ignore the denominators. And now I just have this pretty easy equation to solve. So if I'm going to pick it up from here, how would I solve this now? Add r to the other side. So now I have 6r equals 2, which means that r is not 3, but 1/3, right? 2 divided by 6. That's it. Oh, sorry. That's my answer. When I have an equation, remember, my answer is just a number, right? I'm finding what number makes the whole equation work. So I'm not simplifying things. I'm not, I'm not worried about X, Y, and Z. I just need, my answers are going to be numbers. It's just going to be a number, some number. I don't know what the number is, but there it is. You just figure out whatever you're missing, and we're going to make it happen. So let's jump down to 3. We're off to a good start. I already have 2 denominators the same. They're both x squared. So what would I need to do to get this one on board? Multiply by x over x. Now everybody has the denominator of x squared. So now I get to ignore those denominators. And I'm just going to do x equals 1 plus 6x minus 2. And I just solve it. Your answer is just some number. Anybody have the number yet? I think I have it. Yeah. I think you're right. So, I'm just solving this, right? So I might maybe minus the 6x. So I'd have negative 5x equals 1 and negative 2 is negative 1. Divide by negative 5. I just get 1/5. Is this so bad? Nah. Let's jump down to one like 7 that looks awful. They just look worse than they are, for the most part. So, all the denominators are the same. They're not all the same right now, but I do have something to factor here. So, what are factors of 8 that have to be 6? 2 and 4. Same thing over here, it's the same one, so it's r plus 2, r plus 4. And then I quickly realize, oh, okay, they all already have the r plus 2. The only thing that I need to do is, yeah, this one's just missing the r plus 4. So I'll just squeeze in r plus 4 over r plus 4. And now everybody has the same denominator. You have to be really careful though, because this is a subtraction problem. So when you go ahead and write the equation formed by the numerators as you think it's supposed to be written. You have it? Tell me what you think you're supposed to write.
1 minus r minus 4 equals 8.
Yes. You have to subtract 1 times r plus 4 is just r plus 4, right? You need to subtract both of those bits. So you need a negative r and a negative 4. And now you can just solve like you normally would. Did you get what I got? Is this okay? It seems weird, but I mean, once you try a bunch, it's not so bad. There is something that we do have to talk about. If you look back up at the directions, it says solve each equation. Remember to check for extraneous solutions. What in the heck are they talking about?
What does extraneous even mean?
Great question. Extraneous solution is an answer that I get doing all the math right, but if I take it and I plug it back in, it doesn't work. Or, in our case, we have to be watching out for, what are you never allowed to have in the denominator? You can have a negative, but you can't have a 0. I'm not allowed to have zeros in the denominator. So let's just say I had done all this work and my answer right here had come out to be negative 2. Let's just pretend. So if I got an answer of negative 2, if I went to plug it back into the original, wouldn't it have turned that thing right into a 0? Right? Because negative 2 plus 2, that would make a denominator 0, and I can't have that. So negative 11 isn't going to, that doesn't affect anything here. It doesn't turn any of my pieces. Oh, the same thing with a negative 4. If my answer had been a negative 4, it would have turned that into a 0, so that would be impossible because I can't have zeros in the denominator. So we do just need to be mindful of we can't get zeros in the denominator. So if I look back at the ones that we've already done, 1/5, I can have 1/5 in my denominator all day long. Same thing up here, 1/3, that's fine. But if I had done the work and my answer had come out to be 0, that would be what we call an extraneous solution, because that would make my denominators zeros, and I can't have that. You just throw the answer away. So you say so that particular equation may not have a solution. So just be mindful of that. It happens every now and again that you get one that doesn't work. So like if I'm looking at number 9, I know right away if my answer is 1, positive 1, it can't possibly be, because 1 minus 1 will get me a 0 in a denominator. It's probably going to be some other number, but if it just so happens to be 1, I got to throw it out. So what would I have to throw out in 11? Give me a number right away that you know you'd have to throw away if it came out to be the answer. 8, right? Because it would make that one turn into a 0 in the denominator. And it could be any one of the pieces. So if any denominator turns into a 0, you got to throw it out. So that's what they mean for check for extraneous solutions. Okay? Doesn't come up very often, but you need to know that it exists. There's actually another little bit of terminology. So what I just asked you here on number 11, we would call 8 an excluded value. So if you were taking, I don't know, the MCAS exam and they said, state an excluded value for this equation, you could say 8. So an excluded value is a number that you can't get because it would turn something into a, in this case, a 0 in the denominator. So 8 is an excluded value. 13 would have 0 as an excluded value. All right. Why don't I have you try one without me telling you what to do? How about 6? That looks good. Everybody try 6. Are you guys getting answers for X? Let me hear them. What'd you get? 9 over 2? Couple 9 over 2s? I have no idea what the answer is, so let's see if you're right. What will my common denominator be? 4x squared. I agree. So the first one looks like it just needs a 2 over 2. You're already 4x squared. What does this one need? 4x, correct. Now they all match. So now make sure that you are distributing that 2, right? I have to do 2 times all of that. 2x plus 10 equals 1 plus 4x. So there's my equation, and now I just get to solve. Oh, what am I doing? Did you say 9 over 2? I agree. And that is not going to turn any of my denominators into zeros, so I'm fine. All right, guys, does this make sense? Okay.